scientists, they said that we want to, sort of replicate what a human being can do for one particular task and try to make it automated or create a system that can, do what a human can do. One particular activity, right? And that's why they coined the word artificial intelligence for the first time.
Atul, we spoke about fine-tuning in some of the episodes. We spoke about prompt engineering, right? Now these are different methods, I believe, that are required to implement an AI. There's definitely a lot of other things that are also required to build a complete solution out of it. But when we say purely deploying an AI, right, we're using something like an LLM, what does it take as an approach to solve a problem using AI? What are the different methods that we use?
So, LLM has become like a hot keyword right now, and so you can just assume an LLM as an AI as a service, right? So it's basically giving you processing capabilities that have been trained on dozens and thousands and billions of GBs of data. And the way LLMs actually work is they don't store data. A lot of people actually think that, we have an LLM trained or on Wikipedia, so whatever is written on Wikipedia, if we ask it, it will just spit out exactly what's on Wikipedia, but that's not how it works. What it learns is the probability of the next word. So it's almost like, when we type SMSs or WhatsApp chats or on our texting interface, we have next word prediction, right?
Yeah.
Imagine your next word prediction on another level where you can predict the next 100 or next 1,000 words. So that's basically what an LLM is in its simplest form. Yeah. So
that's where the whole thing comes about, generative AI, right? So you know that you're not just predicting the next word, but you're generating a whole idea based on few keywords that you provide, which is basically prompting the AI.
Right. So I think a good example, I'll just show a really simple way of how an LLM basically works. This is an image on NVIDIA, one of NVIDIA's blogs, and this is how they're explaining it, and I think it's spot on the way they've explained it. So you can see the sky is, and then they add this to the LLM, and now based on whatever data this LLM has been trained on, there's a particular probability for the next word, right? So it could be blue, it could be clear, it could be usual, and maybe this is end of line, right? So here blue has the highest probability, even though it's minus, right? So the output is the sky is blue. Now this is a very low level example. Now imagine this with hundreds of words before the sky is, and it has to predict hundreds of words after the sky is, right? So each next word changes the probability of the next word. So using these probabilities, and LLM basically figures out how to respond, what to respond. So that's why a lot of people see that if you ask the same question twice to an LLM, it may not say the same thing every time. That's because it always takes a slightly different path. Instead of it going maybe from these neurons to that neuron, it may be taking another slightly different path. But overall, it's optimizing for the best possible answer, which can be similar, just the words used are different, right?
Right. So how is it related to this topic called the neural network? Right. So there's a large language model, the LLM, and then there is neural network, which is also another concept used in AI or machine learning.
So our really brilliant scientists here, a couple of years ago, I think in the 50s, they decided, I'm going to go back to where the word AI started from. So it was mentioned first in 55 or 56 at a summer convention at Dartmouth College. And a team of scientists they said that we want to, sort of replicate what a human being can do for one particular task, and try to make it automated, or create a system that can, do what a human can do, one particular activity, right? And that's why they coined the word artificial intelligence for the first time, right? But of course, in the 50s, 60s, 70s, we didn't have any compute. There were a lot of bottlenecks about, centralizing data and all of that. But then as that got, as there wasn't a problem after a while, they started analyzing how our brain worked. So if you want to create something, that a human, for a human, something like a human, you have to try to mimic how the human brain works, right? So that's how neural nets were born.